Okay. Hello guys. So, wait. Okay, hello guys. So, today we are going to learn about cross-origin resource sharing. So, I never learned anything about this, so this is going to be my first time studying this. So, I hope this is going to be very fun, and I hope it goes well. So, let's continue. So let's see the path first. So we are going to know what is CORS, same origin, relaxation, vulnerabilities, and also preventing. Okay, so let's start. Okay, before we start, I'm gonna explain to you guys that I'm going to take notes, but I won't show you guys the notes, but I'll try my best to explain to the best of my understanding, and I hope you guys can understand my explanation. Yeah. So okay, wait, let me set up. Okay, wait, let me see, check out something. Okay, so let's start. Wait, let me set up my notes first before we start. So let me add cross course. So what is CORS? So cross-origin resource sharing is a browser mechanism which enables controlled access to resources located outside of the given domain. Hmm. It extends and adds flexibility to the same origin policy, SOP. Okay, however, it also provides potential for cross-domain attacks. If a website's CORS policy is poorly configured and implemented, CORS is not a protection against cross-origin attacks, such as cross-site request forgery. CORS is not a protection against cross-origin attacks, such as cross-site request forgery. Okay, so let's see the picture. So first, the user is going to get sensitive victim data. Oh, okay. Host vulnerable with a weird origin. Then it allows the origin. What? Okay, so this is pretty interesting. I want to learn this. Okay, let's continue then. Wait, let me keep that picture. Actually looks cool. Wait, what? Edit. Let's make 500. Okay, let's continue. Same origin policy, SOP. The same origin policy is restrictive cross-origin specification that limits the ability for a website to interact with resources outside of the source domain. The same origin policy was defined many years ago in response to potentially malicious cross-domain interactions, such as one website stealing private data from another. Okay, so it's CSRF basically, right? It generally allows a domain to issue requests to other domains, but not to access responses. General allows domain to issue requests to other domains, so it can request other domains but not access the responses. Okay. Relaxation of the same origin policy. The same origin policy is very restrictive, and consequently various approaches have been devised to circumvent the constraints. Many websites interact with subdomains or third-party sites in a way that requires full cross-origin access. A controlled relaxation of the same origin policy is possible using cross-origin resource sharing, CORS. Oh, so CORS is basically the same as SOP, but it's a controlled relaxation of the SOP. Okay. The cross-origin resource sharing protocol uses a set of HTTP headers that define trusted web origins and associated properties such as whether authenticated access is permitted. These are combined in a header exchange. These are combined in a header exchange between a browser and cross-origin website that is trying to access. Okay. So now we are going to learn about the vulnerabilities. So vulnerabilities arising from CORS configuration issues. Many modern websites uses CORS to allow access from subdomains and trusted third parties. Their implementations of course may contain mistakes or be overly lenient to ensure that everything works, and this can result in exploitable vulnerabilities. Okay. So basically, the modern websites usually use CORS to allow access from subdomains or third parties. Yeah. Okay. So CORS vulnerability with basic origin reflection. This website has an insecure CORS configuration in that it trusts all origins. To solve the lab, craft some JavaScript that uses CORS to retrieve the administrator API key and upload the code to your exploit server. The lab is solved when you successfully submit the administrator's API key. Wait. This seems fun. Okay, so this is the URL. Maybe we can make it like fetch. Is it like XSS? I don't understand. I don't really understand actually. I think I need to view the solution. Wait, what? Wait. Let me open up burp suit. Because I know nothing about CORS, so I don't really understand what's happening. Oh yeah, we got the API key. Let's send it to the repeater. And what's the header again? I forgot. Oh yeah, access control allow credentials. Origin. What? Let's try giving it the origin of http evolve.com. Oh yeah, it allows the origin of evolve.com. Observe that the origin, yeah. In a browser, go to the exploit server and enter the following HTML operation. So So let's try copying this. Oh yeah, with what? So I can see what they make them access. So let's understand why this works. What is XML HTTP request? Oh, it's basically a request. Okay, so REC is a XML HTTP request data type, kinda. Then REC listener. Oh, oh, okay. So this function runs when the request is finished. So the REC listener is ran when it's finished. It will first open a GET request to the Academy. Async. Okay. So we chose it to be async with credentials true. What does this mean? Oh, okay. Then it will send it. Then after it sends, load. This is basically the one calling, right? Correct. Response.text. So we can fill response.text like usual, right? Yeah. Could take the response.text, then append it to log key. Wait, let me try to understand the onload. I think I'm gonna ask GPT. Okay, I'm just gonna use the free one. It's okay. Wait, I'm just gonna copy all of them. Check something. Oh, so they access our website. When they access our website, we will open a request to that place, then put them to this location. Why does the location does onload it's the user access in the current page that they are in this script in. Oh yeah, like onload. Yeah, I understand it now. Okay, so I'm gonna save this because it's very cool. A great example, in my opinion. Very great example. Okay, yeah, nice. That was very fun. Great. Okay. Server generated ACAO header from client specified origin header. Some applications need to provide access to a number of other domains. Maintaining a list of allowed domains requires ongoing effort, and any mistakes risk breaking functionality. Some applications take the easy route of effectively allowing access from any other domain. One way to do this by reading the origin header from requests and including a response header stating that the requesting origin is allowed. For example, consider an application that receives from the following requests: get, yes, and then response with access control, yeah, allow, true. These headers state that access is allowed from the requesting domain, and that the cross-origin request can include cookies. Oh, and so will be processed in session. Because the application reflects arbitrary origins in the access control or allow origins header, then this means that absolutely any domain can access resources from the vulnerable domain. If the response contains any sensitive information such as API key or CSRF token, you could retrieve this by placing the for it script on your website. Wait, what? Okay. It's the same, right? Yeah, dark listener, yeah. Errors parsing origin headers. Some application that supports access from multiple origins do so by using a whitelist of allowed origins. When a CORS request is received, the supplied origin is compared to the whitelist. If the origin appears on the whitelist, then it is reflected in the access control allow origin. header so that its access is granted. For example, the application receives a normal request like get data, host normal website.com, origin, innocent website. The application checks the supply origin against its list of allowed origins, and if it's on the list, reflects the origin as follows. Okay. Mistakes often arise when implementing CORS origin whitelist. Some organizations decide to allow access from all their subdomains, including future subdomains not yet in existence, and some applications allow access from various other organizations' domains, including their subdomains. These rules are often implemented by matching URL prefixes or suffixes, or using regular expressions. Any mistakes in the implementation can lead to access being granted to unintended external domains. For example, suppose an application grants access to all domains ending in normalwebsite.com. Ooh, an attacker might be able to gain access by registering the domain hackersnormalwebsite.com. Alternatively, suppose an application grants access to all domains beginning with, oh yeah, this is very interesting. Ooh, this is very cool. I'm gonna save this part. Okay, let's continue. Whitelisted null origin value. The specification of origin header support the value null. Browsers might send the value null in the origin header in various unusual situations. Cross-origin redirects, requests from sales data, requests using the file protocol, sandbox cross-origin requests. What? I don't understand this part. Browser might send the value null, the origin header in various cross-origin data. Request from source data. What? Okay, so sandbox file cross-origin request. So I think I'm gonna save this part because I don't really understand it. I'll hope I'll can understand it in the next part. Okay, this website has an insecure CORS configuration in that it trusts the null origin. Okay. It's taking a while. Let me grab my drink first. I need to drink. Okay, so let's log in first. I think I'm gonna log in at the burp. And let's remove all the history first because yeah. Then let's log in to Winner Peter. So is it in the account details again? Probably, right? Yeah. Let's try giving it an origin of http evolve.com. What happens? Doesn't work. What if null? Okay, so it only allows null. Interesting. Hmm. What if we go to the exploit server and put the same script, but instead let's try to find using headers. Set request header method. Ooh, interesting. Maybe we can change this part. Set request header from the origin. It's a string, right? Origin to null. Then let's view the exploit. So it doesn't work. Hmm. Is it supposed to be down here? I don't think it's... Hmm. Oh, is it because I have... It's a different... Wait. Let me give it this new... Wait. Hmm. Why doesn't it work? Ahem. This is the host, right? Can't they tell if the origin null? Did it work? Hmm. Resource not found. Hmm. Oh, is it like that? For real? For real? Doesn't work. Oh. Hmm. Oh, this is the solution. Oh yeah, because you need iframes, right? So I think I'm gonna take this PLC and use it here. Wait, where we are going to load this details. Remove this part. Then we can put it here. Attacker server. Hup. Let's try. If you exploit, what happens in the access log? Is it in base 64? Ooh, we can do this. Can do this. Okay, okay. So this is free. Wait, what was the place again? Okay, I'm gonna save this in my course in the references because this is very good. Thank you, integrity. Thank you. Thank you. Thank you. Thank you. Okay, now let's send it to the user. Check the access log. Is it the same as before? Hopefully not. Oh, yeah. We got it. Nice. Submit the solution. Yeah, nice. Thank you, integrity. Thank you. Thank you. So we need to make the browser force the origin to be null. We can't use this because yeah, we can't change the origin from the JavaScript. That's good to know. Okay, nice. That's very fun. Let's continue. Refresh. Okay, exploiting XSS via CORS trust relationships. Even correctly configured CORS establishes a trust relationships between two origins. If a website trusts an origin that is vulnerable to cross-site scripting XSS, then an attacker could exploit the XSS to inject some JavaScript that uses CORS to retrieve sensitive information from the site that trusts the vulnerable application. Yeah, okay. Trust origin that vulnerable to cross-site scripting. Then attacker could what? When configured CORS. Okay, so this is only in trust relationships between two websites, right? Yeah, given the following request, get API request API key from the website Origin is the subdomain of the formal website. Okay. The attacker who finds successful vulnerability on subdomain vulnerable website could use that to retrieve the API key using like oh because they can inject the script. Oh, okay, so this is the chaining of accesses, right? This is very cool. Breaking TLS with poorly configured CORS. Suppose an application. Wait, let me save the one from before. Because this sounds cool. Exploiting SSS via CORS trust relationship. Okay, this one's finished. Then breaking TLS with poorly configured CORS. Suppose an application that rigorously employs HTTPS also whitelists a trusted subdomain that is using plain HTTP, for example, when the application receives the following request. Okay. What happens? What? Wait, let me open up the integrity again. This sounds very confusing. I don't understand how TLS could break this. This looks like it created by AI. I don't like this. Do we need like an open redirect on the HTTP, or we can only can spoof it? I don't understand. This is HTTPS, right? What if we put it HTTP? I think I'm gonna go straight to the solution because this one sounds very weird. So it's the same account details. Well, let me test it. So please. Let's try using an origin of no. Yeah, the same as before. It doesn't work. But what if give it the host of HTTP task dot, yeah, it works because it's the subdomain. But how do we trick the user into accessing that? I don't. Hmm. What? For real? So let's try viewing details of this one. It's getting a bit laggy. Let's try intercepting. What? Interesting. We are given two. We are redirected to stock. Okay, interesting. So let's see the for real. Product ID. Good. Let's try giving A. What happens? Is it? Ah, what if we put a script? Script alert one script. Yeah, so we need to actually get a access transformability on the. Yeah, okay. So let's understand this first. So we will put a script that goes to product with an XSS. Oh, the XSS makes a HTML request that request to the account details. So it's like an XSS to CORS. Then we'll create a rack listener to the location. There is our exploit server and give it the response.txt. So let's view the exploit. Doesn't work. Why doesn't it work? It works on the victim, but not us, okay. But yeah, it's okay. So basically, wait, we need to find the accessors. So the problem here that this website uses a function that is located in a subdomain that uses HTTP, and that HTTP made has an XSS vulnerability. So this is very specific. So I went straight to the solution because it's kind of confusing, but it's okay. Nice. Okay, so intranets and CORS without credentials. Most CORS attacks rely on the presence of the response header access control without credentials. Without the header, the victim's browser will refuse to send their cookies, meaning the attacker will only gain access to authenticated content, which they could just as easily access by browsing directly to the target website. However, there is one common situation where an attacker can access a website directly when it's part of an organization intranet and located within a private address space. Internal websites are often held to a lower security standard than external sites, enabling attackers to find vulnerabilities and gain further access. For example, a cross-origin For example, a cross-origin request within a private network may be as follows. Okay. How to prevent CORS-based attacks. CORS vulnerabilities arise primarily as misconfigurations. Prevention is therefore a configuration problem. The following sections describe some effective defenses against CORS attacks. Misconfigurations. So the solution is proper configuration. If a web resource contains sensitive information, the origin should be properly specified in the access control allow origin header. If a web resource contains sensitive information, the origin should be properly specified in the access control allow origin header. Wait. Only allow trusted sites. It may seem obvious, but origin specified in the access control or origin header should only be sites that are trusted. In particular, dynamically reflecting origins from cross-origin requests to the validation is readily exploitable and should be avoided. Dynamically reflecting origins from the cross-origin request. Okay. Avoid while listing null. For using it, yeah. Cross-origin resource calls from the internal documents and sandbox requests can specify no origin. CORS headers should be properly defined. CORS headers should be properly defined in respect of trusted origins for private and public servers. Avoid wildcards in internal networks. Avoid using wildcards in internal networks. Trusting network configurations alone to protect internal resources is not sufficient when internal browsers can access trusted external domains. Yeah. This is the one where we append the name, right? Probably. Yeah, should be. Yeah. Is it? Oh, yeah. 6. CORS is not a substitute for server-side security policies. CORS defines browser behaviors and is never a replacement for server-side protection or sensitive data. An attacker can directly forge a request from any trusted origin. Therefore, web servers should continue to apply protections over sensitive data, such as authentication, session management, in addition to properly configured source. Yeah, so we should always remember to do server-side security policies because CORS doesn't replace all of them. We need to implement all of them with CORS. CORS is like a addition to them. Yeah. Okay, we are done. Nice. So this is day 10, right? So we completed 10 paths, probably. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I have 1, 2, 3, 4, 5, 6, 7 again. We have 7 more paths to clear, and we completed 10. We're very close to ending the series, but yeah, it's been a while. And I know there will be like 1 or 2 paths that will take more than 1 day. Like prototype pollution, I think is going to be hard. I don't think 1 day is enough for 65. Authentication looks fun, but it has a lot of rooms, and also the SQL injection has a lot of the rooms. So I hope I could clear that in 1 day each. Yeah. And after we completed all of the paths, I have an idea because the goal of what I'm doing is the goal is the BSCP. Wait, I don't know. Certification. This is the goal that I'm trying to get. And I noticed that the paths are not in the prerequisites. See? I thought the paths was the one that we have to complete, but either way, I'm going to complete all of them so that I could learn a lot of about websites first before going into the labs. Yeah, but here is the fun part where we're going to exploit cross-site scripting, bind SQL, force OAuth, stay logged in cookie, HTTP request smuggling, okay, SSRF, SQL injections via XML, discovering vulnerabilities quickly with targeted scanning. So yeah, this is going to be in the next event, like the next series after we completed the 17 paths. Yeah, it's going to be fun. Then we are going to complete 5 mystery lab challenges live also. Yeah, okay, that's it for today. Thank you guys for watching. See ya.